All right, today we're going to be looking at the characteristics of acids and bases. You're going to have to forgive any noises or distractions that might happen because I'm recording this at home in my basement and there are children running amok. These notes are a little bit light in terms of what it is you need to know for the test. So this table right here, you'll want to know for the test just different characteristics of acids and bases, which is the reason why this is highlighted in yellow. Acids produce what we call the hydronium ion. This is usually what gives acids all of their chemical properties. Bases produce the hydroxide ion. Both of these are polyatomic ions. Acids taste sour, bases taste bitter. Although you should never taste chemicals. I don't know why this is always like a standard thing to put on there. You shouldn't taste chemicals. This is usually there because if you think of like lemons or grapefruits or something like that, citrus fruits are sour because of the citric acid that is in them. And then the last thing, that acids react with metals to form hydrogen gas, and bases feel slippery. Bases are typically like your soaps. Okay, but anyway, you need to know this table for the test. You're going to see some terms about strong acid and weak acids. And so what I want to point out here, down here highlighted, is the definition of what a strong acid is. Most of the acid molecules have basically split apart. You can see right here in the middle, this is an acid molecule, and that extra proton has gone to the water to make this hydronium ion. And so you can see that it's happened quite often. There's not many acid molecules that stay intact. Now, if we were to compare this to a weak acid, you'll notice that most of the weak acid actually stays together. Right? Only one of them has donated a proton to form this hydronium. And that's the difference between a strong and a weak acid. A strong acid, most of the acid molecules split up and they make the hydronium ion. For weak acids, most stay together, or only a few split up to make the hydronium ion. This is why a strong acid are the types of acids that are in your stomach, that are used to digest your food, or the types of acid used in Breaking Bad to liquefy a body. And weak acids are typically the things that we eat, right? Citric acid, vinegar are all examples of weak acids. The last kind of topic is the pH scale. The pH scale, again, this is highlighted. You will want to know this for the test. Is a scale to measure the acidity of a sample or a solution. So you put a little piece of paper or some kind of strip, or maybe a little probe into it, and it will give you a reading. The pH scale goes from 1 to 14. 1 is very acidic, 14 is very basic, and 7 is neutral. You don't need to worry about how we calculate pH. We're going to cover that later this year. Just know that the scale goes from 1 to 14, and the lower the pH, the more acidic it is. This is more of just kind of FYI. You don't need to know this for the test, but these are just the different ways that we measure pH. The most common, or what you maybe have used before, is litmus paper. This is a paper indicator. It's just a piece of paper that is usually soaked into some kind of chemical that when you put it in, it changes colors. You might also have used, if those of you that have pools or a hot tub, you typically need to check the pH quite often. You put a little strip in, it changes colors. And that's just because they're soaked in different liquids, different chemicals that change color depending upon pH. And that's what this last slide is. This is just an example of all the different chemicals and the colors that they change depending upon the pH. You don't need to know this for the test. It's really just a pretty picture to look at.